Okay, good afternoon, Toastmasters, fellow guests. So a few years back, there was a global crisis that evolved into a debilitating epidemic in the United States and really across the world. People were holding upside down mortgages in the United States. The banking system was kind of faltering and corporate profits were increasing. It was a time of mortgage defaults, government bailouts, and questionable ethical behavior by the centralized banking system. And what time am I speaking of? Of course, the 2008 financial crisis, which I think we all lived through. Maybe if you were in another country, you didn't live through. But you might have seen effects across the world. Yes, this series of events can be characterized by one of the worst economic downturns in the last 200 years. What was the cause of this calamity? I hypothesize that it was the middleman. It was a centralized banking system in the United States. So what's the problem with a centralized banking system? So a centralized banking system, humans are controlling in the center. They're controlling the banking system. So what's wrong with humans? They're infallible. They make mistakes. They work off prejudices. And of course, banks are looking for profits. That's why they exist. And there's also insecurities in a centralized banking system. Hackers can get into your centralized bank account, which is held on a server, steal your identity, take your money. And they can also be robbed. So out of this crisis of 2008, the financial crisis, came something that I think a lot of you might be familiar with. Cryptographic currency, or cryptocurrency. The two primary ones that everyone probably has heard about is Bitcoin and Ethereum. So this was invented in 2009 by Satoshi Nakamoto in a white paper titled A Peer-to-Peer Electronic Cash System. Now Satoshi Nakamoto, there's a lot of mystery around him because he's actually not a person. So this paper came out and no one really knew who Satoshi Nakamoto was. There's lots of conjecture, but no one actually found out who came out with this paper. It's a revolutionary way of doing banking without any banks. So the code or algorithm behind cryptocurrency is called blockchain. The beauty of blockchain is decentralization, which means no single entity, like a bank, owns or controls the database. And it's immutable, means that transactions over the database are tamper resistant, using something called a hashing function. More on hashing in a little bit. So essentially, instead of a centralized banking system where you put trust in a bank, you are putting trust in an algorithm. So trust through algorithm. So what's a block in the blockchain? So here's a block. A block consists of 5 things. So first you have a hash of a previous block, which we'll talk about chaining in a second. A hash looks like this. And I bet, who in here knows what a hash is? All right, 2 know what a hash is, but you all use it every single day of your life. When you log into your bank account, you put your password in, right? The server that has your password, they don't actually have your password. They have the digest of your password, which once your password goes through a hashing function, a digest comes out, and it looks kind of like this. Now for everything, like your password, my password, they're going to be completely different digests. This is a digest. And when you put that password in, the digest is compared against the digest that the web server has on file to give you access. The second thing in a block is a timestamp. I think that's pretty self-explanatory. When you do a cryptographic transaction with blockchain, you're going to get a timestamp for when you did it. And then the data, that's the actual financial transaction. If Brandon is transferring 10 Bitcoin to Brad over here, that's what's going to be put in that block of the blockchain, or the block. And then a nonce, which is a randomly generated number. This helps with confidentiality between the two people that are creating the transaction. And lastly, all those 4 things are appended together, and then they are put through another hash. And this would be an example of what a hash looks like. So, what's a chain? So essentially, a blockchain is a bunch of blocks chained together, which create the blockchain. So how would you say this is used? So here's kind of a pictorial representation of how a blockchain database works. So if I want to transfer 10 Bitcoin to someone in this room, I'm going to log on to my cryptocurrency account. I'm going to find the intended recipient of the exchange, and I'm going to exchange electronic currency, just like we talked about in the block. That data, the timestamp, the nonce, the hash, they're all going to be working together to ensure that that transaction happens. So the entire, in Bitcoin and Ethereum, which are public blockchains, everyone can see everything that's going on. And the entire network sees and validates the transaction through a process called proof of work. So proof of work is how consensus among every single person in the blockchain happens. So proof of work is a whole nother speech in itself, but that is how consensus happens throughout the distributed database. So in conclusion, we talked about the financial crisis of 2008 and how that kind of had someone with the alias of Satoshi Nakamoto came out with this great thing called cryptographic currency, and with blockchain running that cryptographic currency. We talked about what a block is. We talked how blocks chain together is called a blockchain, which runs cryptocurrency. I hope you leave here today with a little bit of interest and a little bit of knowledge about what blockchain is, because a lot of times you see people and they're like, I don't know what blockchain is. You know, make-believe currency running around. It's actually a very unique thing that I'm working on in my thesis, and thanks for your time.
Thank you, Mr. Toastmaster, fellow Toastmasters, most welcome guests. Brandon, especially. I noticed that you still wore your hat as befitting a very serious topic for a very serious speech. So whether you're giving a serious speech or a serious evaluation, it is appropriate to be appropriately hatted. I was intrigued by the title of your speech, Bankless Banking. I mean, that's kind of like waterless water. Again, so great job on that. And I liked how you set up the speech by motivating it by this 2005 financial crisis, which most of us can remember, at least those of us of a certain age. Some of us can remember the financial crisis of 1989 and before, but that's maybe just me and Carl. So good set. In terms of the evaluation of the project was the second project in, it was the third speech, but the second part of two. The purpose was to present a speech, it could be on any topic, and to incorporate the feedback from your previous speech on this. And I'm not sure about that because I didn't have the information of the previous speech, but in terms of the criteria, your voice was very effective. I thought that was one of the strongest parts of it. You used tone, volume, and speed to get your message across. I thought your eye contact was good, except when you weren't looking at your notes, as was previously mentioned. Your gestures were effective. They were a little mild, but for a serious speech like this, that was appropriate. I'm going to address the content of the speech because you had specifically asked about that. And you covered the two most important parts of cryptocurrency, which are hashing and the blockchain idea. And I want to talk a little bit about the hashing. I think you could have explained that a little bit better. That is, I understood everything because I know about that. I think that you could have had, while your slides were very effective, I think to describe the password you could have had a nice diagram with that, where you show the password, the hashing function, and then the gobbledygook, and then show how that matches with the gobbledygook that's stored. The other element that I think it's important to mention is that if even one bit of what you're hashing is off, the hash looks totally different. So it's not like they're close, they're totally, you just simply can't figure out what that one bit difference is. And that's a key aspect of this, because that maintains the integrity of these blocks as they go through. Now, I thought you did an excellent job of explaining how, when you go from one transaction, again, you store that hash, you put extra information in, you then create another hash, and then pass it on to the next person. So that was very effectively done. And one thing I liked what you did with the conclusion, you not only summarized what you had told us, but you gave us a takeaway, which is something that sometimes we miss. So overall, an excellent presentation, and I look forward to many more. Mr. Toastmaster.